students, welcome to IMS GATE Academy. My dear students, we are almost 10 days to the GATE exam, my dear students. So it is the time to test yourself with a classical problems. When I talk about civil engineering, Geotech plays a very important role. It carries a marks of around 10 to 12 marks. So you might have done all the revision. You might have prepared all the formula sheet. You have done all the things, groundwork, what is required for geotechnical subject. But let us test ourselves with a classical questions where these kind of questions will be challenging and also it will help you in the point of GATE exam to solve very easily. My dear students, welcome to the top 10 challenging questions on geotechnical, and we at IMS GATE Academy YouTube channel, we have been conducting this. Okay, very good afternoon. So my dear students, what I would like to tell you here is, in IMS GATE Academy, we offer offline GATE coaching at 800. We offer offline GATE coaching for a duration of 800 hours. My dear students, the material which we provide is like subject-wise material. Along with that, we have exercise book where it covers level 1, level 2, level 3 questions. And also, my dear students, these level 1, level 2, level 3 questions carries multiple choice question, multiple select question and NAT questions. Apart from this, we are also providing GQB GATE question booklet which of last 30 years. Suppose if you want to test yourself with the test series, then we at IMS GATE Academy providing you the chapter wise test, multiple subject test, advanced level subject test and also all India mock test series, which will be a replica of, very good Vishwashar. So which will be a replica of GATE environment. Now see students, what is the agenda? In the top 10 challenging questions is we want to discuss the best questions. So my dear students, always remember that whatever we do the activity in YouTube channel, it is in the perspective of the students to get benefited. And now I don't want to waste your time and I will quickly start the questions, students. Now the first question is, a water tank is supported on 3 columns which form an equilateral triangle configuration. Of the water tank is 200 tons. The spacing of the column is, you can say, 3 meter. Assume that the load on each point, is what, sir? You can say the load on each point is a point load, and find the vertical stress at a depth of 2 meter and under any one of the footing using Bosnick's equation. So it is a very good question in the point of stress distribution. Now my dear students, first let me tell you what do you mean by Bosnick's equation before solving this problem. See students, the equation is simple. What do you mean by Bosnick's equation is, Bosnick's equation says that sigma z, what do you mean by, sir? Suppose if I consider this as a soil strata and if I consider this as the depth of the soil strata, which is z, here we have a load Q, and a load Q is a point load for your information, and the stress at a radial distance R at a depth Z. What is the formula here we have is sigma Z. My dear students, the formula you have to remember is sigma Z is equal to Q by Z square into 3 by 2 pi into 1 upon 1 plus R by Z whole square whole power 5 by 2. Now see students, this formula might be somewhat tough, but you have to remember this formula. Now what is R here? R is the radial distance, and what is Z? Z is nothing but the depth of the soil strata. Now let us discuss this question, students. There was a water tank which is having 3 columns and the water tank is carrying a load of how much, sir? The water tank is carrying a load of 200 tons. Are you getting, my dear students? The water tank is carrying a load of 200 tons. Now see students, how much load it has to take by each column is very important. How much load it has to be taken by each column is very important. Very good afternoon, Vishweshwar. So here, so there are 3 columns, my dear students. There are 3 columns and the total load carrying is how much? It is 200 tons. So what is the load carried by each column is important. Now here, my dear students, load carried by each column can be taken as 200 upon 3. So there are 3 columns which are carrying 200 tons. So the load carried by each column is 66.66 tons. Okay, T means tons. Now my dear students, the spacing between the columns is evident, is clearly, they have given it as equilateral triangle. So they have given all the sides are same. So the spacing between the columns is given as 3 meter, which is in the problem. Now what is trying to ask in this problem, my dear students? What is the stress acting at any one of the column when there is a point load acting on that? So here I will assume for easy calculation, I will assume this as first column, I will assume this as second column, I will assume this as third column. You can assume any column as numberings. Numbering is not an issue. But my dear students, when I explain the stress at a depth Z at a column 1, you have to understand this logic, sir. What is the logic here is the stress of column 1 due to column 2, the stress of column 1 due to column 3 and the stress of column 1 due to its own load. So you can write the stress at a depth 2 meter on a column 1. That is the reason, the beauty of this question is he has asked the stress distribution on any one of the column. He didn't try to find out the stress distribution on a particular column. You can say it can be any column, my dear students. So here the stress can be taken as sigma 11, that is stress on column 1 due to column 1, stress on column 1 due to column 2 and stress on column 1 due to column 3. So you have to find out these things. Now my dear students, if the load is acting exactly on the column, for the column 1 there will be no radial distance. Radial distance will be 0. When I talk about column 1, 2, there will be a radial distance of 3 meter. Because the column 2 is located at 3 meter from first column. Similarly, column 3 is located at 3 meter. Now, I hope you are clear. Now see student, sigma 11 if I have to find out, the formula here is Q by Z square into 3 by 2 pi. The formula of Bosnick's theory, 1 upon 1 plus R by Z whole square whole power 5 by 2. So this is the Bosnick's equation. Now my dear students, let us calculate what is the load here. 66.66 tons divided by Z square is 2 square because Z is, they have asked you at a depth of 2 meter into 3 by 2 pi. Okay. And this entire term will become 1 because R is 0. If R is 0, this entire term will become how much, sir? This entire term will become 1. Now if you solve this, my dear students, the stress on column 1 due to the load at column 1 will be taken as, here if you take this value will be equal to 7.95 ton per meter square. What is the value, sir? 7.95 ton per meter square. Now here, let me tell you, the stress on column 1 due to footing due to column 2 at a depth 2 meter is given by, here in this case, radial distance will be equal to how much, sir? R is equal to 3 meter and Z depth is 2 meter and load will be equal to 66.66 tons. Now here, see students, sigma 12 will be same. Similarly, sigma 13 will be also same. So here if you calculate, what is the formula? Q by Z square into 3 by 2 pi into 1 upon 1 plus R by Z whole square whole power 5 by 2. Now my dear students, let me solve the values. Let us plug in the values. What is Q? 66.66. What is depth? 2 square into 3 by 2 pi into radial distance is how much, sir? Here radial distance will come. Vishweshwar, are you following, sir? Can you please respond in the chat box? So 1 upon 1 plus 3 by 2 whole square whole power 5 by 2. Now my dear students, this will be around how much, sir? This will be how much around? You will get something around 0.43 ton per meter square. Yes or no? Stress. Very good, very good. So here, if I consider the total stress will be 7.95. This is stress on column 1 due to column 1. Stress on column, this will be 0.43 plus 0.43. That is both will be same. Stress on column 1 due to column 2. Stress on column 1 due to column 3. Why both are same, sir? In both the cases, the radial distance is same. So in this case, the total stress will be equal to 8.8 ton per meter square. So my dear students, whenever you are solving some problem, this is very important, sir. What are the key takeaways from that problem? Here it is a Bosnick's equation. So the formula is very important. Q by Z square into 3 by 2 pi 1 upon 1 plus R by Z whole square whole power 5 by 2. That is the key takeaway. But in Bosnick's equation, Q is a point load. And when the load is acting directly on the footing or whatever the point, then the radial distance will be 0. R is nothing but the radial distance. And my dear students, if they give you pressure or intensity of pressure, you have to convert into point load. And this is how we calculate the total stress under any type of footing. When the total load is given, how we distribute the load on each column, that also you have to keep in mind. I hope this solution is clear for you. So let us go on to the next question. My dear students, this is one of the beautiful question in consolidation. Sir, what do you mean by consolidation is? Remember my dear students, a consolidation is nothing but the removal of water from the voids under a static long-term pressure. Now here let me tell you one important thing, sir. The question is, a footing for a water tower carries a load of 900 tons and it rests on a dense sand of 9 meter thickness overing a clay layer of 3 meter thickness. Depth of foundation is 1.5 meter. The clay layer has a liquid limit of 54 percentile. Void ratio 1.08. Saturated unit weight of sand and clay are 1.89 and 1.79 ton per meter cube. Assume the load distribution is 2 vertical to the 1 horizontal. Assume the site is flooded. This has a huge meaning, my dear student. Assume the site is flooded has a huge meaning. It is my sincere request, my dear students, whenever you are writing the GATE exam, you have to take minimum 30 seconds. If the question is large, you have to read the question carefully. You have to understand the given data. Okay. Now, what is the ultimate settlement due to the consolidation of the clay layer? And the second one is the maximum effective stress at the center of the clay layer. So, they have clearly asked us what is the settlement and what is the final effective stress. Now, see student, how do you calculate settlement? Sir, whenever some question is asked, you have to understand, first they have asked you settlement. So, what is the formula for settlement? Sir, in IMS Academy, we have done smart revision, formula sheet, and gate score booster. What we have done here? First we explained all the concepts, then we have done the smart revision which will help you in formulas. Now we are doing the challenging questions. So this is a kind of workflow how best you can learn. So try to get in touch with this IMS Gate Academy YouTube channel. Not only civil engineering, all the branches we are following this, and it will help you in your career to achieve your dream for the gate journey. Now see students, what is the formula for settlement? Here settlement is nothing but delta H is equal to H into Cc upon 1 plus E naught into log of sigma final effective stress upon sigma initial effective stress. So this is the formula for what, sir? Settlement. Agree? Now you have to understand what are the parameters in the settlement. Sir, some people will be overconfident, but whenever you learn some formula, how this formula will actually depend on other formulas. That is very important. And what are the parameters which are very important is very important. Now what is H? Here my dear students, H is nothing but the thickness of the clay layer. What is Cc? Coefficient of compression index. Now I will tell you how they have not given you Cc. So here H, thickness of clay layer is 3 meter, which is evident in the question. Agree? Now how do you find out the coefficient of compression index? My dear students, coefficient of compression index is given by the formula 0.009 into liquid limit minus 10 percentile. So here, what is the Cc value? Which is equal to 0.009. And my dear students, here the liquid limit is given in the problem as 54 percentile. So 54 minus 10, and if you solve this, you will get a value of 0.396. So the coefficient of compression index is 0.396. Now what is the void ratio? Void ratio is given as 1.08. Now my dear students, our agenda is simple. We have to calculate the initial effective stress and the final effective stress. So how do you calculate the initial effective stress and final effective stress? So here see students, there was a clay layer which is having a thickness of 3 meter. On top of it, there is a sand layer of how much, sir? 9 meter. And for your information students, here we have a foundation. Here we have a foundation which is of thickness how much, sir? Which is of thickness 1.5 meter. Which is of thickness 1.5 meter. Now we have to calculate the stress at the center of clay layer. This is a very, very important point in calculating the consolidation settlement for clay layers. Sir, consolidation happens only in clay layers. And another important thing is effective stress should be calculated at the center of clay layer only. What, sir? The effective stress should be calculated at the center of clay layer only. This is a very, very important point. Now, my dear students, here we have this is 1.5. So, this is also 1.5. So, this depth will be equal to, sir, 9 minus 1.5 is 7.5. Again 7.5 plus 1.5. So, here this is 7.5 and this is also 1.5. So, here what is the total, sir? Total will be equal to 9 meter. Agree? Now, how do you calculate the effective stress? How do you calculate the effective stress? Sir, the most important thing is it is flooded. Flooded means water table at top. Now, the sand layer has gamma sat is equal to 1.89 ton per meter cube. And clay layer, the saturated of clay is 1.79 ton per meter cube. If you have observed our quick revision or smart revision or gate score booster, I have told you how to calculate the effective stress. Whenever there is a water table, while calculating the effective stress, my dear students, gamma sat will be replaced by gamma dash. What, sir? Gamma sat will be replaced by gamma dash. So here you can write it as effective stress can be written as gamma dash of sand, and the thickness of sand is 9 meter plus gamma dash of clay, and the thickness of clay is 1.5 meter. Now see, my dear students, what do you mean by submerged unit weight? It is nothing but the difference between the saturated unit weight and unit weight of water. So here we calculate as 1.89 minus 1 into 9 plus gamma dash of clay is 1.79 minus 1 into 1.5. Now see students, 0.9 into 9, 8.1 or 0.79 into 1.5, it will be almost 1. So if you solve this, you will get a value of 9.19 ton per meter square. So the effective stress sigma naught is very clear for you. Now how do you calculate the final effective stress? Now my dear students, final effective stress is nothing but the initial effective stress plus the additional stress due to the applied load. Now my dear students, here it has applied a load of 900 tons. Okay, and it is a square footing for your information. So the width of the footing is 3.6. Now my dear students, how the distribution is there? Load distribution, 2 vertical, 1 horizontal. Now my dear students, if I find this depth is anyhow 9, and this value, if I calculate this value, this will be equal to 9 by 2. From similar triangle concept, if I take x and this as y, x by y can be written as 1 by 2, x can be written as y by 2. Here y is nothing but 9 by 2. So what is this total width is 4.5 plus 3.6 plus 4.6, 4.5. This will be equal to 12.6 meter. Am I correct or wrong, my dear students? So here, how do you calculate delta sigma? Sir, see here, my dear students, how this will be seen in the problem. Suppose here there is a load acting here and the load is supposed to distribute in this way. So it is a square of width 12.6 meter. Load is 900. So load upon area, load is how much, sir? 900 upon 12.6 square. If you see 12.6 square, it will be around 156 or something. If you calculate, you will get 156. 12 square is 144, 169. 12.6 will be 25, means it will be around 16. It will be around 160 or something, sir. If you calculate this, you will get a value of 5.67 ton per meter square. What is this value, my dear students? Delta sigma is 5.67 ton per meter square. So here, what is the final effective stress is? Initial effective stress is 9.19 ton per meter square, and delta sigma is how much, sir? 5.67. So it will be around roughly 14.86 ton per meter square. So you have known each and every term in the problem. So here, let us solve here, see student. Delta H is equal to, what is the formula? H into, what is H? Thickness of clay layer. H into Cc upon 1 plus E naught into log of sigma final upon sigma initial effective stress. So here, my dear students, what is the thickness of the clay layer? The thickness of the clay layer is nothing but 3 meter. And what is Cc? 0.396 upon 1 plus void ratio is 1.08 into log of sigma final. What do you mean by sigma final here? 14 point, how much sir we got? 14.86 I think. 14.86 upon sigma initial is 5.19 ton per meter square. You will get a value of 0.119 meter. And if they ask you in mm, so 119 mm is the settlement. So my dear students, let me tell you what are the key pointers in this problem is, whenever they ask you settlement, delta H can be taken as H into Cc upon 1 plus E naught into log of sigma final upon sigma initial. And remember my dear students, H should be taken thickness of the clay layer. Effective stress should be calculated as at the center of the clay layer. Final effective stress is initial effective stress plus delta sigma. Delta sigma is a kind of stress which is induced due to the load acting. If you calculate the effective stress, it is due to the self weight of the soil, whereas delta sigma is due to the application of the load. When you keep these points in your notebook, definitely you can solve the problem. I hope you are clear, my dear students. Now, let us understand ourselves. Actually, if you see, the question is very simple here. A smooth vertical wall is pushed. This is a very interesting question. In 2021, we have seen this kind of question, my dear students. Sir, when you are pushing something, it is passive. When you are pulling something, then it is active. When it is at stationary, it is at rest pressure. So, my dear students, they will not give you calculate active pressure, calculate passive pressure or calculate at rest pressure. Based on the yielding of the soil mass. If the yielding of the soil mass is due to stretching, then it is due to active earth pressure. If the yielding of soil mass is due to compression, then it is passive earth pressure. If the yielding mass, no yielding, then it is at rest pressure. So, here shear angle resistance is C20, 530 degrees, unit weight 20, surface carries 20. What is the total passive earth pressure? Now, let us understand. Sir, we have to calculate the total passive pressure and I will tell you how to calculate the force also. Now, what are the key points to solve this problem? Sir, this is very important. Whenever you are solving a problem, solving the problem in a generic way is very important. What do you mean by generic way is, if that question is asked in n ways, n different ways, but using this generic method, you can solve the problem. Okay. So, my dear students, in GATE exam, there is no point of short trick. It is application oriented learning. You have to come up with the application, then you have to come up with the short trick. Okay. Now here, let me tell you what is the points here. First, calculate the coefficient of earth pressure. What sir? What is the first step? Calculate the coefficient of earth pressure. So here, how do you calculate the coefficient of earth pressure, my dear students? How do you calculate the coefficient of earth pressure? Okay. Sir, see, how do you calculate the coefficient of earth pressure is K naught. Here it is passive pressure. So Kp. Kp is equal to 1 minus sin phi upon 1 plus sin phi. And what is the angle of phi, my dear students? The angle of phi here is nothing but 30 degrees. So, Kp can be taken as 1 minus sin 30 upon 1 plus sin 30 degrees. So, it is evident that Kp, sir, again we have done one mistake. Is it Kp 1 minus sin phi or Kp? You can write here Ka. Because Ka formula is 1 minus sin phi upon 1 plus sin phi, right? So Ka will be equal to 1 by 3. But remember, Kp will be equal to 1 upon Ka. So Kp will be equal to 1 upon 1 by 3. So that will be equal to 3. So remember students, how do you calculate the coefficient is very, very important. So we have calculated the coefficient. Now let me tell you the second step. Second step is calculate the vertical stress or calculate the total vertical stress. What sir? Calculate the total vertical stress. My dear students, how do we calculate the total vertical stress, sir? Can anyone tell me? How do you calculate the total vertical stress? So here, it was a soil, it was a retaining wall of height how much, my dear students? Of 4 meter height. So here it carries a surcharge loading of 20 kilonewton per meter square. The surcharge loading is 20 kilonewton per meter square. And there is no water table here, luckily, so we can take directly. So gamma is taken as 20 kilonewton per meter cube. And the width of the soil strata, or sorry, depth of the soil strata is 4 meter. Now, how do you calculate the vertical stress? Here see, the vertical stress at top due to surcharge, it will be equal to 20. Next, at bottom, this value will be equal to 20 and this value will be equal to gamma into Z. So 20 into 4. So the actual stress at bottom is 100. So second step is nothing but finding the calculate the vertical stress. Once you are done with the vertical stress, now calculate the active or passive. Here it is passive. So calculate passive earth pressure or any earth pressure. If it is passive, you have to calculate passive. If it is active, you have to calculate active. But remember, my dear students, here you have to understand whether it is a cohesive soil or cohesionless soil. If it is a cohesive soil, the formulas are different. If it is a cohesive soil, the formulas are different. So here, active passive pressure. Passive pressure is given as Kp into sigma V plus 2C root Kp. Okay, this is the passive pressure formula for cohesive soils. Okay, here the coefficient of passive pressure is 3. So the vertical stress diagram, if you remember, the value at top is 20. The value at bottom is 100. So my dear students, let me calculate the value at top. So here, passive pressure at top is 3 into 20 plus cohesion is given as 2 into 20 and Kp is given as root 3. What is the value of root 3? It is nothing but 1.728 or 1.73. If you see 60 and this is 69.28. Now, passive pressure at top is given by the formula 129.28. What is the passive pressure at top? It is given as 129.28. Now, how do you calculate the passive pressure at bottom? How do you calculate the passive pressure at bottom? It is given by the formula Kp into sigma V plus 2C root Kp. Now, my dear students, what is the value of vertical stress at bottom? The value of the vertical stress at bottom is 100. So, just plug in that values in the formula. If you calculate here 3 into 100 plus 2C, 2 into 20 into root 3. My dear students, when I plug in these values in the formula, you will get a value of passive pressure at bottom is 369.28 kilonewton per meter square. Agree? Very good. So here, my dear students, the passive pressure at top and also at bottom is clear. Now, how do you calculate the force? How do you calculate the force? Sir, see, first once you have done the passive pressure calculation, just draw the diagram here. So that pressure at top is 129.28 upon 369, here it is 369.28, and the height of the vertical wall is 4 meter. Now let me tell you how do you calculate the force. The force is nothing but the area of the pressure diagram. So it is a trapezoid in shape. So the force can be taken as half into H into A plus B, where A and B are the sides of the trapezoid. So just substitute, the height is 4 meter. So half into 4 into, what is the sides here? 129.28 plus 369.28. Now my dear students, this will be taken as 2. So 369 point plus 129.28. Here 0.72, 0.72. So 1.44 into 2, 2.88. If you do this calculation, you will get a value of 997.12 kilonewton meter. So the units are important. So what is the force? Force is nothing but the area of the pressure diagram. Now what is the fifth point? Where does this force acts? Force acts at its centroid. What, sir? Force acts at its centroid. Now here, my dear students, okay, when I talk about centroid, sir, when you are studying engineering mechanics, you will have a better idea or better perspective. Like you divide this into a rectangle and you divide this into a triangle and you will calculate the centroid of a composite section. But let me tell you, my dear students, if it is a trapezoid section, the trapezoid section is given by the formula directly h by 3 into 2a plus b by a plus b. Usually I don't want to learn through the formula, but still for your easy understanding I am telling. See students, if I take a as this one, then the centroid will be from bottom. If I take this as b, then the centroid will be from top. So you should be very careful what should be the a term. Because if you are confused with that term, divide this into rectangle and triangle and do for a composite section. That is the better idea for you. Now h is how much, sir, here? If I use this formula, I can get 4 by 3 and a is given as 2 into 129.28 plus 369.28 upon 129.28 plus 369.28. Now see students, you know anyhow, this will be 0.72, 0.72, 1.44. So 498.56. And if you solve this, it will roughly in this bracket, you will get 1.3. 1.3 into 1.33, you will get a value of 1.69 meter. Actually, my dear students, if you are preparing for IES, calculations are also very important because there is no calculator allowed. But we are confined to GATE, at least you will have a virtual calculator. My better suggestion for you is, please be accustomed with the virtual calculator. And if you are not aware of that, in one of our playlists, we have provided how to use the virtual calculator, which will definitely save your time around 5 minutes. So using virtual calculator is very important. It adds value addition in speeding up your calculations. Now I hope this problem has created an awareness how to solve a problem on earth pressure. Now let me tell you what are the steps in earth pressure. First, calculate the coefficient of earth pressure. I should say the word calculate the respective, because here in this problem it is passive. So you have calculated passive coefficient. If it is active, you have to calculate active. If it is at rest, you have to calculate at rest. Second point you have to do is, you have to calculate the vertical stress. You have to calculate what, sir? Vertical stress. After finding the vertical stress, there can be a challenging question also. If there is a water table is present. Remember, my dear students, vertical stress should be written as total stress plus pore water pressure, because you cannot multiply with the coefficient of earth pressure for pore water pressure, Because why we are multiplying with the coefficient is, we are resolving the vertical stress into a horizontal stress. But Pascal's law states that pore water pressure is same in all directions. Hence, we need not to multiply with K. This is a very important, one of the, in IIT Delhi, sir, like nowadays we are not having any interviews. In some of the IITs, when we have an interview, this was one of the question way back in 10 years back, sir, in the interview. Okay. Now, the third question is calculate the earth pressure. The fourth point is the area of the pressure diagram is force. And the fifth point is calculating the centroid, you will be finding the force. So, if you have any issue with finding the moment of inertia, or if you are having any problem in the engineering mechanics, we also have the engineering mechanics video in the playlist. You can go and watch those videos. Now, let us go through the next question. Now, see, sir, whenever you are reading some gate question, try to understand the perspective, try to understand the key points and how this problem can be solved in a generic way. Okay. So, I hope you are clear. Now, the side of a canal is shown in the figure. The properties are 20 kilonewton per meter cube, C is 25 kilonewton per meter square, is shown in the figure. When the canal runs with full water level, when the canal gets emptied suddenly, EAD area is given as 33 meters square. Now, see students, sir, why do you want to study about the topic called stability of slopes? Sir, stability of slopes, we have two failures. One is rotational failure and another one is translational failure. In this problem, it is a rotational failure. So, how do you calculate the factor of safety for rotational failure? How do you calculate the factor of safety for rotational failure? I would be very happy if anyone comment in the comment box. So, what is the factor of safety for rotational failure? And for your information, my dear students, rotational failure occurs in curved surface. The factor of safety for rotational failure is given by the formula resisting moment upon driving moment. What, sir? The factor of safety is given by the formula resisting moment upon driving moment. Sir, see, some people will ask me, sir, when I am writing the gate exam, this formula how I have to remember? Sir, if I have written driving moment upon resisting moment, how to remember this formula? Sir, the logical thinking is important. The factor of safety is always greater than 1. For the factor of safety to be greater than 1, you should ensure that resisting moment is greater than driving moment. If your resisting force is more, definitely failure will be less, or there are less chances of failure. So, my dear students, this is how you have to learn. So, factor of safety is nothing but resisting moment upon driving moment. Now, here in the problem, he has given phi is equal to 0 analysis. Sir, what does it phi is equal to 0 analysis? Let me tell you, shear strength is a function of effective stress, sir. When you write shear strength, it is C plus sigma dash tan phi, my dear students. That means when he told in the problem that phi is 0, this entire term will be 0. That means the resisting force will be taken care only by C. Sir, you might have studied in friction also. Based on the surface, your coefficient of friction will be validated. Here, the resisting force will taken by shear strength, and the shear strength is controlled only by cohesion. Actually, shear strength is controlled by cohesion and friction. But my dear students, here phi is 0. So, resisting moment, if I talk, it is occurring along a curved surface, sir. It is occurring along a curved surface. So, what is cohesion? It is nothing but a stress. What is moment? Moment is nothing but force into perpendicular distance. Are you following, my dear students? Moment is nothing but force into perpendicular distance. So, here when I talk about resisting moment, here you can write, sir, C into L into 1. Sir, this is stress, L into 1 is area, and it is located at a rotation at a distance of R. So CLR will be your resisting moment. Driving moment, which is trying to force you. If you are climbing a mountain, when you are falling down, due to self-weight, you will come down. So driving means is always due to your self-weight. W into X bar. X bar is the center of gravity distance. So here, what is the factor of safety formula? CLR upon W into X bar. Now see students, it's my sincere advice in GATE exam. Whenever you are solving a problem, the concept behind is very important. How generic you can solve the problem. What are the terms associated? How this question can be asked. These things will help you to brainstorm yourself to do the GATE questions. So here factor of safety is nothing but CLR upon W into X bar. Here CLR, everything is given. Weight, how do you calculate? That is the beauty of this problem, sir. Now see students, when canal runs with full of water, sir, when canal runs with full of water, it says that this is the first case. When canal is run with full of water, it is evident that it is a saturated soil, because voids are completely filled with water. So you have to take the saturated unit weight. So gamma sat can be written as weight upon volume. Now my agenda, I know cohesion, I know length of the arc, I know the radius, but I don't know the weight. So our intention is how to find out the weight. So weight can be written as gamma sat into volume. And how do you write this volume? This is written as gamma sat into area into 1 meter. Here in the problem they have given gamma sat as 20 into 33 into 1. Now see student, here what is, sir, when canal runs with full water. If I take gamma sat, this will come with what, sir? 660. But let me tell you, this will come for sudden drawdown. This will come for sudden drawdown. I'll tell you why I have written like this also. This is for case 2, sir. If you are taking sudden drawdown, then you will use gamma sat. Now what? Then you have to ask yourself what you will do when canal runs with full water. Now I told you one question, students. Whenever you are calculating the effective stress is calculated by taking submerged unit weight into account if the water table is present. Now here water table is present. In sudden drawdown, tank is full of water. What is the condition? Saturated. Now it is getting empty. But here it is a submerged unit weight case. So in this case, I will take gamma dash, which is equal to gamma sat minus gamma W. Here I will assume for my easy calculation, gamma W as 10. Don't ask me, sir, if we have to take 9.81. Just for my easy calculation, I am taking. So you can take it as 20 minus 9.81. So this will be equal to 10.19 kilonewton per meter cube. Now, if we calculate the gamma dash is equal to weight by volume, in this case, if I take it as 10, you will get 10. Weight is equal to gamma dash into volume. So 10 into 33 into 1. It will be equal to 330 kilonewton. So you are evident and clear, sir. What are the cases? When the canal runs with full water table, you have to take gamma dash. When the canal gets emptied suddenly, you have to take gamma sat. Now let us understand how do you calculate the factor of safety for case 1. For case 1, it is given by the formula C into LR upon W into X bar. Cohesion is given as 20. Length of the arc, sir, it is given as theta as 96 degrees. To convert into radians, it is pi by 180. Okay, into length, R, this is theta. Sir, if you have a R radius and this is theta, length of arc is given as R theta. So 20 L is, our radius is 8 meter. and theta is 96 degrees. I will convert into radian. Pi by 180 into radius again 8 meter upon weight 330 and x bar is 2 meter, I think. 1 second. Let me see the diagram. X bar is 2 meter. So if you solve this, you will get factor of safety as 4.06. How much value you will get, my dear students? You will get a value of 4.06. Now, how do you calculate in the second case? In second case, sir, in sudden drawdown, instead of 330, it will be replaced by 660. So, actually it will be reduced to half. So, the factor of safety will be equal to 2.03. Now, my dear students, as a structural engineer or as a geotechnical engineer, which case is best? If you ask me, you have to understand when you are providing more factor of safety means there are more chances of failure. When there are more chances of failure, you have to provide more factor of safety. If there are less chances of failure, you can provide less factor of safety. So you should be smart in designing the structure or a geotechnical site. Okay, I hope you are clear, my dear students. Now let me understand you, my dear students. A settlement was under a pressure of load intensity with a size of plate 30. The settlement under a footing of size 1.8 and 1.8. Now let me understand for you, what do you mean by ultimate load? What do you mean by ultimate load? And what do you mean by settlement? What do you mean by ultimate load and what do you mean by settlement? Sir, the problem seems to be very easy, but you should know the concept here. That is the reason I have taken these questions. Now, I have taken a site. This is my excavation pit. Okay. Here I have kept some plate and I am trying to apply the load. The load at which the plate starts sinking. I will apply 10 kg, 20 kg, 30 kg, 40 kg. At 40 kg, the plate starts sinking. That load is called ultimate load. The load at which the plate starts sinking is the ultimate load. How much the plate has sinked, that is nothing but the settlement. So, my dear students, the agenda of plate load test is to find out the ultimate load as well as to find out the settlement. So, here we have two different formulas to calculate the settlement. Settlement is given by the formula SF by SP is equal to BF, breadth of the foundation, upon breadth of the plate. This formula is for clayey soils. What is this formula? This formula is for clayey soils. When I talk about, my dear students, sandy soils, SF by SP is equal to breadth of the foundation upon breadth of the plate plus 0.3 upon breadth of the foundation plus 0.3 whole square. And here let me tell you one thing important. The breadth of foundation and plate should be substituted in meters. What, sir? Again and again. The important note in this formula. Sir, it's a ratio. If you substitute in meter, centimeter, whatever, it is okay. Because it's a ratio. Both should be same units. If you substitute cm cancel. But here there is a factor called 0.3. Due to that, they have considered this formula taking breadth of the foundation and plate in meters only. So, my dear students, breadth of the foundation as well as the breadth of the plate should be considered in meters only. Are you agreed, my dear students? Very good, very good. So, here let me do settlement of the foundation. I don't know. Settlement of the plate 6 mm. Sir, units are important. That is the reason I have taken this simple question. And it was asked in 2 times in GATE exam, sir. Sometimes what happens with the students, right? My dear students, let me tell you one small story. When you are running a 100-meter stretch, you will prepare for 5-kilometer run. Similarly, you should not overthink yourself. There are some set of basic standard questions where these basic questions are mandatory to learn. So you have to prepare to an extent. Even if it is difficult, you can solve. But you should never leave the basic and standard questions. That you should keep in mind, my dear student. So here SF by SP is equal to breadth of the foundation is 1.8 upon breadth of the plate is 0.3, because 30 centimeter plate is given in 30 centimeter. It is not meter. So 30 centimeter is 0.3 meter. So 0.3 plus 0.3 upon breadth of the plate is 0.3 upon 1.8 plus 0.3 whole square. Now see students, you will get roughly around 2.9 or something, this value. You will solve this 2.95 or something. Settlement of foundation you will get as 17.63 mm. Sir, let me tell you, see what is the observation you have to see here. This is a ratio, it doesn't have any units. But settlement is given in mm, so the settlement of plate is given in mm. So settlement of foundation is also in mm. I hope you are clear with this problem. Very good, very good. Now, my dear student, there is another question, sir. Just read the question. A square group of piles. 9 piles were driven in a soft clay to a large dia. The diameter and the length of the piles are 30 centimeter, 10 meter respectively. If the unconfined compressive strength is 8 ton per meter square, the spacing between the piles is 90 centimeter. If the factor of safety is 2.5, adhesion factor is 0.75. So, my dear students, it is an interesting problem. So, it is a question which is asked in where, sir? Pile foundation, and they are asking about a topic called group capacity. They are asking about a topic called what, sir? Group capacity. Sir, when I talk about group capacity, what do you mean by group capacity? A group capacity, there are two things, sir. When you talk about a group of piles, most of the people will think that the group capacity of the piles will be equal to the sum of the individual capacities of the piles. That means if I take group capacity as capital X, you will take it as x1 plus x2 so on xn. Where x1, x2, xn are the sum of the individual carrying capacities of the pile. It is absolutely wrong. It is never equal to this. Why? Because of stress overlap. The stress overlap will not allow you to say that, or practically it will not happen that the group capacity of the piles is never equal to the sum of the individual capacities of the pile. Here there are two chances of failures. One is the individual failure, and other one we have is the block failure. What, sir? One is the individual failure and block failure. Now see students, the beauty of the question in any structural engineering or any engineering in civil, when you design something, you have to design for higher loads. When you are allowing something, you have to allow lesser. That is the reason LSM method is very much appreciated. I am talking about RCC, but to be frank, how the design accepts is when you ensure double safety and most economical, then that section is most efficient. So if here we have two failures, individual and block failure, calculate the values separately and whatever is the minimum value will be your answer. So here when I talk about the individual failure, group capacity of individual failure is N into QUI. So you can say N into FB into AB plus Fs into AS. How many piles are there in that question, my dear students? In that group there are 4 piles. So here you can write it as 9 piles, sorry. What is FB? For clays, remember this is very important. FB for clays is given as C into NC. In this problem, my dear students, they have given you unconfined compressive strength as 8 ton per meter square. Actually, when they have given you unconfined compressive strength, the cohesion will be equal to half of the unconfined compressive strength. So this will be equal to 8 upon 2, that will be equal to 4 ton per meter square. This you have to remember, students, because in overlook this mistake will happen. What is that is, people have a tendency to take the value that it is 8. But when the term unconfined compressive strength come into picture, cohesion is nothing but the half of the unconfined compressive strength. So here C is nothing but 4 and NC value is standard, that is 9, and AB, area at the base, pi by 4 d square. The dia of the pile given in the question is 30 centimeter or 0.3 meter. EFS is alpha into C. Alpha is the adhesion factor which is given as 0.75 into 4 into pi dl. Pi is 0.3, length is 10 meter. Okay. Now see students, 36, 9 pi is around 27 and you will get around 28 into 0.09 or 0.09 means 0.1, it will be around 3. If I do here 3, 9, 2.7, 27, you will get around a value of, if you do this, you will get a value of 277.37 tons. What's that? 277.37 tons. This is the value of group capacity considering individual failure. Considering which failure, sir? Considering the individual failure. Considering individual failure, this is the group capacity. Okay? I hope you are clear. Now we have to consider as a block, as a single pipe. Now it is a square group. So that means rows and columns will be equal. So here, my dear students, if I take this as a column, there are 9 groups. The spacing between the columns is 0.9 and here also 0.9. If I take spacing as S, dia of the pile is half dia and half dia. So here if I take a length or side, 2 into 0.9 plus 0.3, this will be equal to 2.1 meter. What is this value, sir? L will be equal to 2.1 meter. Now let me tell you what is the area of the block. Area of the block will be equal to, what is the area of a square? It is nothing but S square. So this will be equal to 2.1 square, that will be equal to 4.41 meter square. When I talk about surface area, it should be pi dl. Sorry, surface area means what, sir? It is not a circle, it is a square. Perimeter is 4s into length of the pile. So it is equal to 4 into 2.1 into 10, that is equal to 84 meter square. So surface area is 84, area at the base is 4.41. Now see students, how do you calculate the block group capacity? How do you calculate the group capacity? See students, group capacity is given by the formula FB into capital AB plus FS into capital AS. Okay. Now see students, when I talk about FB into capital AB, C is 4, NC is 9, AB is 4.41 plus FS alpha C 0.75 into 4 into 84. Now see students, 0.75 into 4 is 3, 3 into 84 is 252, 252, 36 around. If you do this, 252 around 36, 136, 144, 162, you will get a value of 410.7 or something. What is the value we got here, sir? 277. What is the value you are getting here? 410, which is lowest. We have to take the lowest value. Lowest value is how much, sir? Or minimum value you have to 277.7 tons. Now they have not asked you ultimate load, they are asking safe load. Safe load for pile and foundations are different, sir. For pile, it is nothing but safe load is equal to ultimate load by factor of safety. Ultimate load is how much, sir? 277.37 or 7, sorry. 277.7 divided by 2.5. It will be almost 111 tons. So here my agenda is simple, students. Whenever there is a group capacity asked, you have to calculate the individual capacity of the pile as a group. You have to calculate as a group, block as a, you have to calculate. There are separate formulas for sand and clay. Here it is clay, so the end bearing resistance is C into NC. Cohesion is half of the unconfined compressive strength. NC value is 9. When I talk about FS, skin friction resistance, it is alpha into C, where alpha is the adhesion factor. So the agenda is simple. Whichever is the minimum value of the two failures will be considered as the safe load. As the ultimate load. I hope you are clear. Now, it's a beautiful question, sir. It's a very simple question if you know the concept. The plastic limit and liquid limit of a soil are 33 percentile and 45 percentile. The percentage volume change from liquid limit to dry state is 36 of the dry volume. Similarly, the percentage volume change from plastic limit to dry state is 24 percentile. Calculate the shrinkage limit and shrinkage ratio. Sir, see, people has to understand the Atterberg limits. Atterberg limits are nothing but the water contents at which soil passes from one state to the other state. We have different Atterberg limits. One is the liquid limit, plastic limit and shrinkage limit. Now, how do you calculate this? Now, see students, if I have this as a graph, okay. Now, if I consider this as a line, here we have is, this point is called liquid limit, this point is called plastic limit, and this point is called shrinkage limit. Here this is called dry volume, this is plastic volume, this is volume at liquid limit. So we have different volumes at different states. But in the problem, they have given volume change from liquid limit to dry state is 36 percentile of dry volume. Similarly, my dear students, the volume change from plastic state to dry state is 24 percentile of dry volume. So here this change is 36 and this change plastic to dry state is 24. Now what will be this change, sir? Total is 36, this is 24. So 36 minus 24 is 12. Or you can see this here. The volume change from liquid limit to plastic limit, if you do the both minus, you will get 12 percentile of VD. Sir, whenever you have seen this chart, you should be evident that the slopes are same. Now if I take the slope, liquid limit minus plastic limit upon corresponding water contents, WL minus WP. That means what is this, sir? dy by dx. The change in the y coordinate upon the change in the x coordinate. Similarly is equal to Vp minus Vd upon Wp minus Ws. Now see students, what is the volume change from liquid limit to plastic limit? It is 12 percentile of Vd. What is liquid limit minus plastic limit? It is 45% minus 33 percentile. And what is the plastic limit to dry limit state? What is the value? What is the value, sir? It is nothing but the 24 percentile. If I am not wrong, plastic to dry state is 24. Upon plastic limit is how much, sir? What is plastic limit they have given? 33 or 33 minus Ws. So here it will be 1. Now if you solve this, shrinkage limit will be equal to 33 minus 24 percentile. That will be equal to 9 percentile, which is equal to 0.09. What is shrinkage limit, sir? Shrinkage limit is equal to how much? It is equal to 0.09. Okay. Now what is shrinkage ratio, they can ask you. What is shrinkage ratio? Shrinkage ratio is nothing but the volume change. Sir, this is very important. Volume change expressed in terms of dry volume. Volume change expressed in terms of dry volume to the corresponding change in water contents. Okay. So here what is the volume change is, if you consider volume change from liquid limit to dry state is 36 percentile upon Vd and liquid limit is how much, sir? 45 percentile. Plastic limit is 9 percentile. If you do this, you will get a value of shrinkage ratio as 1. So my dear students, the volume change shrinkage ratio means it is the volume change expressed in terms of dry volume to the corresponding change in water content is nothing but the shrinkage ratio. See students, whenever you are learning Atterberg limits, you should understand this graph. Okay, this graph indicates when it is more than liquid limit, we call it as liquid state. If it is between plastic to liquid, then it is plastic state. If it is between shrinkage and this is semi-solid state. And this is less than shrinkage limit, then it is solid state. So my dear students, all these things you should be aware. What is liquid limit means? It is the water content at which soil has small shear resistance. Plastic limit means it is the water content at which soil can be rolled into 3 mm diameter without breaking. Shrinkage limit means it is the maximum water content up to which any change in loss of moisture will not cause any change in volume. That means up to shrinkage limit, the volume remains constant. So this is all about this problem. I hope you have enjoyed this problem. Now see students, there was a question here. Sir, actually when you are solving this question, you should have an idea. Sieve analysis on a dry soil sample of mass 1000 grams. Okay, sorry sir. A sieve analysis on a dry soil sample of mass 1000 grams. 850 grams and 250 grams was passing through 4.75 mm and 0.75 mm respectively. Liquid limit and plastic limit of the soil are 42 and 20 percentile. Okay sir, see here. Now when I see here 850 grams is passing through. So here let me tell you. We have one sieve sir, 4.75 mm sieve. In this sieve, there is almost 850 grams passing. Okay. And from this it is passing is 850. From this again 250 is passing through 0.75 mm. Sir, this is very important. Actually, how do you classify fine grained and coarse grained is very important. So if I consider here 850 grams means here it is 150 grams are retained on 4.75. Now see students, let me tell you, out of 850 grams, 250 grams is passing. So what is the retained here is 600 grams. Sir, this is very important. And here we have is 250 grams. So more than 50% is retained between 4.75 mm and 75 micron. More than 50% is retained. So it is evident or it is clear that it is a sandy soil. Sir, this is important. Let me tell you one thing, sir. A soil is said to be fine grained if more than 50% is retained on 4.7. If more than 50% is passing through 4.75. A soil is said to be coarse grained if more than 50% is retained on 4.75 micron sieve. But here if you see the sieve sizes, in between these we have sand. Here more than 50% is sand. So we talk, sir, when you classify the soil, we give importance to the composition of the soil. So it is evident it is sand. Okay, now we have to understand whether it is a silty sand or clayey sand. Now see students, here liquid limit is given as 42. Plastic limit is given as 20. Now if I calculate A chart, IP is equal to 0.73 into WL minus 20. So if you calculate 0.73 into 42 minus 20, if you will get 16.06 if I am not wrong. But see students, what is the value from here? It is 22. So A line is located at 16.06. The value you got is 22. So it is above A line. Above A line means it is clay. Below A line means it is silt. So the answer here is SC, which is clayey sand. So the first option is clear. Sir, in soil composition, you should be giving importance to the composition of the soil. I hope you have enjoyed this question, sir. Okay. Now see, going to the last question here. The true and the apparent specific gravity of a fully saturated sample. True is how much, sir? It is 2.7. Fully saturated mass specific gravity is given, that is gamma sat by gamma W is given as 2. Okay. Now my dear students, you know gamma sat is equal to gamma W into G plus E upon 1 plus E. Now from the problem, gamma sat by gamma W is equal to G plus E upon 1 plus E. Anyhow, you know gamma sat by gamma W is 2. 2 is equal to 2.7 plus E upon 1 plus E. On solving, you will get E is equal to 0.7. Sir, why I have given this question here is, it is might not be challenging. But how to take what is mass specific gravity, what is true specific gravity. True specific gravity will never change, sir. Mass specific gravity changes with respect to the state of the soil. I hope these sessions will create an impact for you. I hope you have enjoyed the session on Geotech. My dear students, if you have liked this session, definitely subscribe our IMS Gate Academy YouTube channel. In this YouTube channel, understand the procedure, sir. We started with the Gate Score Booster, where we have been giving the insights of the subject. In the second part, we have done the smart revision, how we have to get accustomed to the formula sheet. And the third one is the top 10 challenging questions, where you can practice yourself and test yourself where you are. So it is a progressive channel where it will be helpful for the students to achieve their success. And my dear students, IMS Gate Academy has offline center at Vijayawada near Bench Circle and at Bangalore near Jayanagar office. We are providing 800 plus hours of gate coaching offline. We are providing the online gate coaching. We are giving you the self-recorded lessons. In addition to this, the material which we have prepared contains subject-wise tests, chapter-wise tests, multiple subject tests, advanced level tests, and all India mock tests. In addition to this, my dear students, we are giving you the 30 years gate question booklet with all the key pointers. So then what are you waiting for? If you are really preparing for the GATE 25 and 26, then if you are from Bangalore or Vijayawada, then contact our Jayanagar office. We have Mr. Rehman. He will be explaining, the Student Awareness Committee member. He will be explaining you all the what are the benefits through the GATE exam and what actually we provide. I hope these sessions will give you more and more insights of the subjects, and you will be habituated to solve the most typical GATE questions. Thank you, my dear students, and all the best for GATE 24 exam.